We would like to construct the graph of this quadratic. Why would we want to do that? The reason we would do that is that there is a lot of information about the relationship between x and y on display in the picture. What I mean is this. Here's an example. Here's the x-axis here. Now suppose we're over here on the x-axis and we're traveling to the right, which we usually do. So what happens in this relationship? Well, as we're here, as we're at that input value, our output value is up here. But then what happens is we travel to the right, right? As x gets bigger, you can see what's going to happen here. The output values, the verticals, are getting smaller. So if I think about this in terms of input and output, what's happening is this. If I'm anywhere on this graph here, anywhere on my relationship, at any point in time in my relationship, if I start increasing the input values, what happens to the output values? Well, you can see right over here, as I increase the input values, right, I'm increasing the input values because the x's are going this way. What happens? Well, the y's, the output values are decreasing. They're decreasing, and then they slow down. Right here, they stop for an instant in time, and then they turn around, and as the inputs keep getting bigger and bigger, the outputs are getting bigger and bigger. And not only that, but look at these 2 points right here. You see that point right there, right where I'm at here? Well, that's the output as being 0, right? So here, the output is 0, and I can see, or estimate anyway, the input value that produces that. So can you see that right there? What does it look like? It looks like maybe, well, this is -2, that's about half. Looks like at -1, when the input is -1, the output is 0. And also over here, it looks like when the input is 3, the output is 0. Now that might be important information for us because I would like to know what are my break-even points. The break-even points is what do I put in just to get nothing back? And there's even more information I get from that. You see this point down here? That y-intercept? That looks to me like it's, well, what, -6? Right, so that tells me that when x is 0, y is -6, or in terms of input-output, when the input is 0, the output is -6 units. So, for example, if the input was time, as time goes by, you come into some situation at time 0, right? Start your clock, you start your observation. Where are you? Well, you're down 6 units already. So just to start with, you're down. So it's nice to know what your start value is, what values are going to produce zeros for your output, and then what's the overall trend? The overall trend here, as x increases, as the inputs increase, the outputs decrease, but then at this point here, at some particular input value, they stop and they turn around and then they start to increase. Right? That's a lot of information about a relationship. To construct this graph by hand, by pencil, I'm going to find a few important characteristics. I'm going to find, first of all, where does this curve cross the x-axis, right? What are those zeros? These are called zeros. What makes the output 0? So what are those input values that create 0 for the output? So I'm looking to find the x values that produce 0 for y. So I want y to be 0. So back here, I'm going to set y equal to 0 and see if I can find x. So how about 0 equals, and then it's 2x squared minus 4x minus 6. Now this is solving a quadratic equation, which we've done before. So we'll try factoring. Now I see there's a 2 common to each one of these terms, so let's factor that out first. 2 times the quantity, x squared minus 2x minus 3. Now I think we can factor that trinomial, so 0 equals 2 times, right, or parentheses, anticipating we can do this. About x and x, let's go with the 3 and 1, the only way to get it, and I think this is going to be minus 3 plus 1. All right, so the x values that produce 0, we have them. Right, from here and from here, we're going to get what? X equals 3 and -1. Let's just look at our graph and see if those seem reasonable. I've got a 3 here. Follow it over to the graph. Does it look like it crosses at 3? Yeah, it does. Right, I've got 2, 4, so right in the middle is about 3. And then I've got this other 0 over here, -1. Follow it over here. Does that look like it crosses at -1? It does. Now here's the thing with looking at a graph. You know, looking at this graph, You think that's about -1 and you think that's about 3, but you don't know exactly. You don't know for sure. Graphs help us just estimate values. We've done it algebraically and got the exact values. And now what I want to know is this point right here. When the input is 0, what's the start value? What's the output at 0? So let's do this. Let's set, this is what, x equals 0? So let's put 0 back in for these x's and see what we compute. So now we will get y is equal to 2 times 0 squared minus 4 times 0 minus 6. So this is just going to be y equals -6. Now, does that look reasonable? So when x is 0, right, when x is 0 up here, sure enough, that looks like y is equal to -6. Now, there's another feature that I would like to get here, and I would like to get the coordinates of this turnaround point right here, all right? That's called the vertex. So that point right there is called the vertex, and I would like to get the coordinates of that point. Now, what does it look like just from this picture? It looks like if you come over 1, down 8. So it looks like 1, 8, but we don't know that for sure. Now, we have a formula for getting the x value of a parabola. We have a formula for getting this value right here. I'll write it right down here as an ordered pair. It's going to be -b over 2a, and then we'll substitute that in to get the y value. Now, what is this b and the a? Well, that comes from this form right here. So I've written this in the form of this. I'll write it here. It's ax squared plus bx plus c, where a is the coefficient of the squared term, b is the coefficient of the linear term, first degree term, and c is the constant. So what have we got for ours? So what do we have for a, b, and c? We'll get them all. We need only a and b in the formula, but let's get them all while we're here. So what is a? Well, a is the coefficient of the squared term, and the coefficient of the squared term for us is 2. And what about b? B is the coefficient of the linear term, and for us, that b is -4, so we'll have -4, and let's go ahead and get it. What is c? What is c? C is the constant. It's -6. All right, so let's write -6 here. So for the vertex, we're going to get x equals -b over 2a. So that's going to be -b. Now what was b? All right, b was -4. So -4, or the opposite of -4, over 2 times a. And what was a? A was 2. All right, so this gives us what? 4 over 4. Well, there's 1. Now, before we go any further, does that look like it could be right? The x value of that vertex is 1. If I come over here and look at that vertex, what does it look like to you? Looks like 1, sure enough. Okay, so I think we've got that. Now I need to get the y value. So to get the y value, well, I know what x is. X is 1. Just put x1 right back in here and compute. So to get the y, we will get 2 times 1 squared minus 4 times 1 minus 6. So y is equal to, well, what do we get here? 1 squared is 1 times 2. So we're at 2 minus 4 is -2, minus 6 is -8. So that vertex is at 1 and -8. And let's just check that -8. Does that look reasonable? So if you come over here, it looks like the x coordinate is 1, and sure enough, the y coordinate looks to be -8. I think we've got it. So if we were going to graph this by hand, by a pencil, ourselves, instead of having a computer generate it, we'll write the x-intercepts. So what are the x-intercepts? They occur at -1 and 3. The y-intercept is -6, and that vertex is here at 1 and -8. Let's plot those points. So I'll get those x-intercepts first. I've got 1 at -1 right here, 1 at 3 right here. The y-intercept is -6 right here, and then I've got that vertex over 1 down 8. That looks like it's right here. You know, I've got these points here that I'm going to try to draw a curve through, but if I want a little better curve, it might be better to have a point up here and a point up here, or even this point here, although I can kind of guess that. But I could get a point up here. What if we choose -2? If you put -2 in for x, let's see where that takes us, and maybe put 4 in for x. See where that takes us. All right, so I get y equals 10. So let's plot that point. Where are we? We are at -2 and 10, so I'll go to -2 and all the way up here to 10. That looks like it probably should work pretty well. I'll put a point right there. These parabolas, these are symmetric about a line through the vertex. If I take this, look at the vertex, and draw a line right through it here, the parabola is symmetric about that line. That means that one side is just a mirror image of the other. So here I am at this line of symmetry. If I go 1, 2, 3 to the left, I could get another point by going 1, 2, 3 to the right. Now I could get this point by putting what? I could get that by putting 4 into our equation here, into our equation, and I'd end up with 10 again. So now, as best you can, pass a smooth curve through these points. All right, not too bad. Here we have it.